Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazam bin Raziman and country is BE11203. Question 1A. 1 row. First step, we have to analyze homogeneous by using a lambda. Before that, we have to change the position of t into the right side. Then we have to insert into homogeneous formula. Then we get x dv by dx equal to v of 2 minus v plus 3 divided by 1 minus 2v. Then we have to exchange dv by dx and integrate. To solve the question of dv, we have to use u, v of 2 minus v plus 3. And we have to differentiate it, become 2v minus 1. We have to find what is dv. So the dv is 1 over minus open bracket 1 minus 2v close bracket dv. Then we use this and replace into dv. Integrate these two, du and dx, become negative log u equal to log x plus c. X, we replace back u. Then we have to replace v equal to x over t. The next question is, we have to construct the equation. These are the exact differential equations. We have to analyze m and n. After we analyze m and n, we have to differentiate these two. And we got the answer m and n is equal. That is, we have to insert into the formula. We choose m. After we get the u, we have to compare m and n. What is gy? Then we got gy is 4y. We have to integrate 4y, become 2y power of 2 plus c. Then we have to insert gy into u equations.
Assalamualaikum and hi, my name is Muhammad Shazam. My calculator number is BE11203. I will explain for the question 1e. So the question given is y x dy over dx equal to 2 bracket 2 square plus x square close bracket. And the question given is y equal to minus 1, and the question show y equal to plus minus x over 4 square root 9 x square minus 2. So for the first step, we must use the homogeneous. So homogeneous we put the lambda. After we get the lambda, we must put in the dy over dx equal to x dv over dx plus v, and y we must substitute equal to xv. So after we change the y equal to xv, and we get the v2v plus 2 over v. After that we get the square root v over v2 v square plus 2 dv integrate equal to integrate 1 over x dx. But v over v2 plus 2 we must use the substitution method, and we get the 1 over 2 ln v square plus 2. After that we must find the c. So the c we get the 3 over 4c. After that we put c in the equation y square over x square plus 2 over 1 over 2 equal to xc. C we replace with 3 over 4c, and after we replace and simplify, we get the v square root x square over 16 square root bracket 9x square minus 32, and we get the answer is y equal to plus minus x over 4 square root 9x square minus 32. We continue to question 1 c1. The question is x dy over dx plus 2y equal to x plus x. So the question we must use the linear division equation. So the formula is dy over dx plus pxy equal to qx. So the question we must find px and qx. After that we must find I. After we get I, we put in the v dot I equal to square root qx dot I dx, and we get y dot x square equal to square root e power of x dot x, and we use the by part method, and we get x e exponent minus exponent power of x plus c, and after that the answer is y equal to exponent power of x over x minus exponent power of x over x square plus c over x power of 2. In just my symbol lab for the answer. Continue to the question of C2. The question given is di over dt plus I sin t equal to sin t. So question is we must use the linear division equation. So the question is d1 over dx plus p xy equal to qx, and the question given is I bracket 5 equal to exponent. So we must find the px and qx. After that we must find the I. We get e exponent power of negative cos t, and the second we must find the v dot I, and we get the I dot exponent power of negative cos t equal to square root sin t dot exponent power of negative cos dt, and this is we must use the substitution method, and we get exponent power of negative cos t plus c. After that we find the I. So I we get the 1 plus c t cos t. After that we use the I equal to exponent, and we get the c equal to e minus e. After that cos 1 we get the cos y and negative 1, and the answer we get the I equal to 1 plus exponent power of minus exponent cos square get exponent power of cos t. Show my symbol lab.
Hi, I'm Assalamualaikum. My name is BEE11203. This matrix number BE20013. I'm going to do the solution for question 2 in this order input. To prove my answer, I'm using the wolfram mathematical, which what is A and what is the fx. So the A is 1 because this A, this is B, and this is C, and this is fx. So A equal to 1, f is equal to exponent x. So the equation we must do the complementary function, which is we must do convert to the quadratic equation, which is represented by x squared, and this is m, and this is 1 equal to 0 because this is quadratic. So we find m1 equal to 3 plus minus 2i. So for this is the case that we must using the YC equation. So A is 3x, 3 is alpha, cos 2x is beta, and plus b is equal to 3x sin 2x. So settle for the complementary function. Second y, we must do solve the Wallis theorem. So first y, we must find y1 and y2. This is y1 and this is y2. So first y, we must do the shape y1 and y2. So we have like we can create the 3x plus minus 2 3x plus y is equal to the shape of 2x and x negative sin x. The second one we integrate y2. So we get the 3x plus 3x sin 2x and 3x cos 2x. So in the Wallis integration, we must integrate y1 and y prime is y2 y2 prime. So we get here 3x sin 2x cos 2x plus 2x cos 2x minus 3x x by x. Yes, 3x cos 2x sin 2x minus plus 3x cos 2x plus 2x. So we get 3x plus 3x and we get what 3x cos 2x minus 3x sin 2x sin 2x. So the one we must get the general solution by using variation of parameter. So variation of parameter, first we must determine a and x, a1 and exponent x, and second one we find the yc, Wronskian, and now we must calculate the u and v. So u formula equal to negative integrate y2 times fx divided by Wronskian times a dx plus a. So we get the negative 1 over 2 integrate sin 2x divided by exponent 2x dx plus a. So for this equations we must solve the integrate part. So we keluarkan we solve. So also we must do what we must solve the integration. So we use the y part direction. So we define the v prime and this is u. So get the u prime e negative x negative 2 and we get the v integrate sin x. So we must solve the v also. So I let the x to the u and u over the x equal to 2. So the u dx equal to 1 over 2 du. So we solve the u and the u and the u and the 1 over 2 du to the 2x and dx. So we get v equal to negative 1 over 2 cos 2x. So after we define, we insert the equation and solve and we get negative 1 over 2 negative x cos 2x and integrate negative x cos 2x dx. So this part we must solve. So we must integrate negative 2x cos 2x dx. So we solve. We also use the y part integration and we get 1 over 2 negative 2x sin 2x plus integrate negative 2x sin 2x. And we insert this to the this and we get negative 1 over 2 x negative x cos 2x minus 1 over 2 x negative sin 2x plus minus 2 minus integrate negative 2x sin 2x. So this is what we write back and we get sin divided by x negative 2x equal u because we want to this is the subject. We get u equal to negative 1 over 4 negative 2x bracket cos 2x plus sin 2x. So now we get u to integrate sin 2x over sin 2x back and we get the answer of this equation. So we put this and we put this value to the u which is this. So we get the u equal to 1 over a exponent negative 2x cos 2x plus sin 2x close bracket plus a. Settle for u and for v. We use the formula positive integrate y1 fx over Wronskian times a. So we get this plus b. And we move up the 1 over 2 and we get the 1 over 2 integrate cos 2x over exponent 2x dx plus b. So we must to solve the integrate part and we solve and we get this and we replace the integrate exponent negative 2x sin x by derivative. So we replace it and we get this cos 2x over exponent 2x equal 1 over 2 exponent negative 2x bracket sin 2x negative cos 2x close bracket negative integrate exponent negative 2x cos 2x dx. Okay. So we find the we must rewrite back and we let this be equal to u and we get u equal to 1 over 4 exponent negative 2x bracket sin 2x minus cos 2x equal to integrate cos 2x over exponent 2x. So the v we insert the integrate cos 2x over exponent 2x equal and we solve we find v equal to 1 over a exponent negative 2x bracket sin 2x negative cos 2x close bracket plus b. So we find the u and v. And now we go to the general solution. So the first general solution we must know that y equal to u times y1 plus v times y2. So we solve the u y1 first and we get the answer 1 over 8 exponent x cos 2x plus 1 over 8 exponent x cos 2x sin 2x plus a exponent 3x cos 2x. So after we find that we must solve v and y2. So we multiply v and y2 and we get the 1 over 8 exponent x sin 2x negative 1 over 8 exponent x cos 2x sin 2x plus b exponent 3x sin 2x. So we sum to this equation to get the general solution and we get this 1 over a exponent x cos 2x plus sin 2x close bracket plus a exponent 3x cos 2x plus b exponent 3x sin 2x and the final answer is 1 over 8 exponent x plus a exponent 3x cos 2x plus b exponent 3x sin 2x because we simplify the cos 2x plus sin 2x equal to 1. So for the answer on the mathematical the answer just until on this because they not to simplify this equal to 1. So the answer 1 over 8 exponent x, this is right, and plus a exponent 3x cos 2x equal to this part, exponent 3x, C2 cos 2x, and plus B exponent 3x sin 2x. We use this. So the equation is right. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Azura binti Abdul Halim, and my number matrix is BE1120088, and I'll be presenting for question 3. This is the question for topic 3 for homogeneous and non-homogeneous system. So let's see, the first question here is y1 prime is equal to 6, y1 plus y2, and y2 prime is equal to 5, y1 plus 2y2. So first of all, we need to find the delta. This delta is equal to 7 and is equal to 1. After that, we need to find the first eigenvector, which is 1, 1, s. And then for the second delta, we used to find the eigenvector, the second eigenvector, which is 1 and negative 5s. So from the eigenvector obtained, we can check if it is linearly independent or not. And then we got the general solution, which is C1, 1, 1, eigenvector 1, and exponent 7x plus C2, eigenvector 2, which is 1 and negative 5, and exponent x. For the second question is B1. The equation above was stated with exponent 4 exponent 7x and 10 exponent 7x. This is the non-homogeneous system. So first of all, we need to find the we just the same like this, find the eigenvector, and then we get the YC solution, and then we need to find the YP. The YP is equal to YC. Therefore, we need to differentiate the YP to get the different from this. And then we compare YP with Y, which is the first solution up here. Yes, the YP without prime. And then from here we will get the U1 and U2, which is 1 and 1, because both are positive s. And then we compare again to get the value of V1 and V2. We assume V1 is equal to S and V2 is equal to S plus 1, and then we get the the Y solution, which is C plus YP. And then, so this is the YP that we obtained from the calculation, 5x plus 5 and 5x plus 6, and then exponent 7x. And then the last question, for question B2, it gave us the, the initial condition. So we put all of the initial condition inside the equation for y1s and y2s to get the C1 and C2 value. We get C1 is equal to negative 10 over 3 and C2 is equal to 1 over 3. So the final solution is equal to ys 10 over 3 for eigenvector 1, 1, 1, exponent 7x plus 1 over 3, eigenvector 2, 1, negative 5, exponent x, and plus 5x plus 5, exponent 7x, 5x plus 6, exponent 7x for the YP solution. Alright, next we move on to the simulation. As you can see from here, I used the MATLAB software to get the solution for question 3. First of all, we need to represent y1 and y1x and y2x in the coding, and then we define the equation, and then the MATLAB will get the first equation from the question, which is here, and then we will rewrite the coding to ask the MATLAB to solve for this equation for non-homogeneous. So which is here and here for y2, which is the equation that we get here. And then move on to question B1. As usual, we need to declare first y1x, y2x, and then we put the matrix inside. This is matrix for y, and then this is matrix for g. And then we ask the MATLAB to solve the equation here, and we got the equation for non-homogeneous here. And then we command the MATLAB to solve it, and then it get the solution for y1 and y2 for non-homogeneous equation, which is here. And then this is in the MATLAB. For question B2, as usual, we declare it, and then we put the matrices, and then the MATLAB will produce the equation. And then we put the initial condition for the MATLAB to find the solution for y1 and y2, which we got here. And then for your information, the MATLAB solution and the manual solution is a bit different, because V1, we declare here V1 is equal to S, but for MATLAB, the V1 was declared as S, negative S over 30, so it is slightly different from the MATLAB solution and the manual solution. Yep. I think that's all from me. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatia binti Harun and my metric number is BE11203. Now I would like to explain to you about the solution of question 4a. And the question is s over s squared plus 2s plus 4. For this equation, we need to use the CTS method, that was complete the square method. Firstly, to solve this equation, we need to solve the denominator with complex square. To complete the square, we need to take half of the big term, and in this case, the big term is 2. So we need to take 1 over 2, multiply with 2, and we need to square all of this, and it becomes 1. Then we need to add and subtract 1 in the bottom. Essentially, we are adding by 0, so we will add 1 and minus 1 in this denominator. So it becomes s squared plus 2s plus 1 plus 4 and minus 1. Then this will make a perfect square when we put a bracket between the b term and c term. From this, we will get the new denominator, which is s plus 2 squared plus 3. Next, we need to square root the c term and square it. So it becomes square root 3 to the power of 2. Next, we need to do the complete square method for the denominator too. So we add 1 and minus 1 to the denominator. And we will get the new solution, which is s plus 1 minus 1 equal s plus 1 to the power of 2 plus square root 3 to the power of 2. And from this equation, we can separate it into two different equations. So it will become s plus 1, which is s minus 1 equal s minus 1 to the power of 2 plus square root 3 to the power of 2 minus 1 over square root of 3 multiply with square root of 3 over s minus negative 1 over the power of 2 plus square root 3 to the power of 2. The reason we multiply it with 1 over square root of 3 because when we multiply the equation, we will get the denominator as 1. So from this we can solve it using the inverse Laplace table. And from this equation, we get a equal to -1 and b equal to square root 3. And when we use the inverse Laplace table, we get the final answer as exponent negative t cos square root 3t minus 1 over square root 3 exponent negative 3 sines exponent 3t. Look at the question 4b, which is the equation is s over s squared plus 1 multiply with s squared plus 2s plus 4. From this question, we know that we need to use the partial fraction method, which is we need to separate the denominator into 2. That was s squared plus 1 and s squared plus 2s plus 4. And to do that, we need to use this. Which is as plus b and cs plus d, so we can get the value. And from this, we need to multiply the denominator with the denominator. So we get s equal to as plus b multiplied with s squared plus 2s plus 4 plus cs plus d multiplied with s squared plus 1. And this is the result when we multiply this equation. And from this, we can get the value of a, b, c, and d when we compare the left hand side with the right hand side. And from the comparison, we get the value of a equal to 3 over 13, b equal to 2 over 13, c equal to negative 3 over 13, and d equal to negative 8 over 13. And all of this value will be added to the equation, so it becomes 3s plus 2 over 13 multiplied with s squared plus 1 plus with negative 3s, negative 8 over 13, s squared plus 2s plus 4. And this is the new equation. So from this equation, we can separate the equation into 2. And when we separate the equation into 2, from what I can see, we can separate the second equation into one more equation, which is we need to use the CTS method. So we need to take the rhythm, half of the rhythm, and square it and get it into the denominator to get the numerator. So we get the numerator as s plus 1 square plus 3. And from this, we can separate the equation again into 2, which is 3s plus 3 minus 5 over s plus 1 square plus 3. And from this, from 2 of this equation, we can take out negative 3 over 30 for the first equation and negative 5 over 30 for the second equation. And this is the new equation for the question. Next, we can inverse Laplace the first equation into 2, which is we can separate the equation into 2, which is 3s plus 2. And this is the new equation. And then, I forgot to do one step for the CDS method, which is square 3 and square root 3 square. Put the square root 3 square to the equation. Okay, so from this equation, we can use the inverse Laplace table to get the final answer. So the final answer is 3 over 13 cos t plus 2 over 13 sin t, negative 3 over 13 exponent, negative 3 cos square root 3 t, minus 5 over 13 exponent negative 3, 1 over square root 3 sin square root 3 t. And this is the final answer for question 4b. Take a look at question 4c. The question already gives the value of L, R, and C, which is L equal to 1 Henry, R equal to 20 ohm, and C equal to 0.25 farads. And the ET value also given, which is sin t minus sin t h open bracket t minus pi close bracket. And this is the second given in the question. To solve this question, we need to use the PBL method, which is just fill in the ET value in the formula, and this is the formula, and I already fill in the ET value, and we just need to solve this equation, and what we got for the answer is this: dt over dt plus 2i plus 4, and this I t dt equal to sin t minus sin t multiply with h open bracket e negative pi close bracket. And lastly, let's look at the 4D question. And to solve this question, we need to apply the Laplace transform on the both sides of this equation. So firstly, we need to solve this equation, and we got this si s minus IO plus 2is plus 4 multiplied with is over s equal to 1 over s squared plus 1 minus exponent negative pi s 1 over s squared plus 1. And from this equation, the equation that we already solved using the inverse Laplace table, we got this equation, which is the simplified one. We already simplified this equation and we got this. And then we need to solve the equation using the Laplace transform, and this is the final answer for the solution. This is the final answer for the question. Thank you.